Hello friends and welcome to the channel. How are you friends? Hope you are doing well and I hope you can gather all the knowledge in this world. So today we are going to talk about Fibonacci sequence and golden ratio and how mathematics is related to nature through example of Fibonacci sequence. Don't forget to press bell icon to get notified about the next video. So let's start. First let's talk about what is Fibonacci sequence. The Fibonacci sequence is one of the most famous formulas in mathematics. Each number in the sequence is the sum of the two numbers that precede it. So, the sequence goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. The mathematical equation describing it is xn plus 2 equals xn plus 1 plus xn. A mainstay of high school and undergraduate classes, it's been called nature's secret code, and nature's universal rule. It is said to govern the dimensions of everything from the Great Pyramid at Giza, to the iconic seashell that likely graced the cover of your school math textbook. And odds are, almost everything you know about it is wrong. So then, what's the real story behind this famous sequence? Many sources claim it was first discovered or invented by Leonardo Fibonacci. The Italian mathematician, who was born around AD 1170, was originally known as Leonardo of Pisa, said Keith Devlin, a mathematician at Stanford University. Only in the 19th century did historians come up with the nickname Fibonacci, roughly meaning, son of the Fibonacci clan, to distinguish the mathematician from another famous Leonardo of Pisa. Large numbers that defined the universe, but Leonardo of Pisa did not actually discover the sequence, who is also the author of Finding Fibonacci, the quest to rediscover the forgotten mathematical genius who changed the world, Princeton University Press, 2017. Ancient Sanskrit texts that use the Hindu-Arabic numeral system first mention it, and those predate Leonardo of Pisa by centuries. It's been around forever. However, in 1202 Leonardo of Pisa published the massive tome Liber Abaci, a mathematics cookbook for how to do calculations. Written for tradesmen, Liber Abaci laid out Hindu-Arabic arithmetic useful for tracking profits, losses, remaining loan balances and so on. In one place in the book, Leonardo of Pisa introduces the sequence with a problem involving rabbits. The problem goes as follows: start with a male and a female rabbit. After a month, they mature and produce a litter with another male and female rabbit. A month later, those rabbits reproduce and out comes, you guessed it, another male and female, who also can mate after a month. Ignore the wildly improbable biology here. After a year, how many rabbits would you have? The answer, it turns out, is 144, and the formula used to get to that answer is what's now known as the Fibonacci sequence. Liber Abaci first introduced the sequence to the Western world. But after a few scant paragraphs on breeding rabbits, Leonardo of Pisa never mentioned the sequence again. In fact, it was mostly forgotten until the 19th century, when mathematicians worked out more about the sequence's mathematical properties. In 1877, French mathematician Édouard Lucas officially named the rabbit problem the Fibonacci sequence. Devlin said, "But what exactly is the significance of the Fibonacci sequence? Other than being a neat teaching tool, it shows up in a few places in nature. However, it's not some secret code that governs the architecture of the universe. It's true that the Fibonacci sequence is tightly connected to what's now known as the golden ratio, which is not even a true ratio because it's an irrational number. Simply put, the ratio of the numbers in the sequence, as the sequence goes to infinity, approaches the golden ratio, which is 1.61803398874989484882. From there, mathematicians can calculate what's called the golden spiral, or a logarithmic spiral whose growth factor equals the golden ratio. The 9 most massive numbers in existence. The golden ratio does seem to capture some types of plant growth. For instance, the spiral arrangement of leaves or petals on some plants follows the golden ratio. Pinecons exhibit a golden spiral, as do the seeds in a sunflower, according to Phyllotaxis, a systemic study in plant morphogenesis, Cambridge University Press, 1994. But there are just as many plants that do not follow this rule. It's not God's only rule for growing things, let's put it that way. And perhaps the most famous example of all, the seashell known as the nautilus, does not in fact grow new cells according to the Fibonacci sequence. When people start to draw connections to the human body, art and architecture, links to the Fibonacci sequence go from tenuous to downright fictional. It would take a large book to document all the misinformation about the golden ratio, much of which is simply the repetition of the same errors by different authors. George Markowski, a mathematician who was then at the University of Maine, wrote in a 1992 paper in the College Mathematics Journal. Much of this misinformation can be attributed to an 1855 book by the German psychologist Adolf Zeising. Zeising claimed the proportions of the human body were based on the golden ratio. The golden ratio sprouted golden rectangles, golden triangles and all sorts of theories about where these iconic dimensions crop up. Since then, people have said the golden ratio can be found in the dimensions of the Pyramid at Giza, the Parthenon, Leonardo da Vinci's Vitruvian Man and a bevy of Renaissance buildings. Overarching claims about the ratio being uniquely pleasing to the human eye have been stated uncritically. All these claims, when they're tested, are measurably false. We're good pattern recognizers. We can see a pattern regardless of whether it's there or not. It's all just wishful thinking. And perhaps the most famous example of all, the seashell known as the nautilus, does not in fact grow new cells according to the Fibonacci sequence. So that's all for today. And if you get any type of knowledge from this video, then give it a like and don't forget to subscribe. Meet you in next video.